All right, welcome back for day 3 of polynomials. All right, so let's start off with our warm up. If you know how to do this, you go ahead and pause it and you go do the warm up yourself. This is a time for you to gather your thoughts, think if you remember these things. If not, follow it along. All right, but please be doing them with us and writing it down. All right, the more you write down, the more you'll remember. All right, area of a rectangle. I'm going to stop there. When I think area of a rectangle, you should automatically go to area is length times width, or you may think base times height. So there's 2 dimensions. Well, when I'm given something that looks like this, what do I need to do to find the 2 dimensions, our length and our width? Well, I put a hint here, think factor. Okay, we multiply to bring it all together to get the area. Well, you got to break it apart. Well, what do we know how to do? We know how to factor. All right. Yesterday, we took a look at factoring like this, where there was nothing out in front. So how do we factor something like that? All right. We can put x and x, and we're looking for factors of -18 that add to 3. All right. Things that multiply to be -18. Well, if I do -9 and 2, that gives me -7, not +3. So I can mark that out. All right. -6 and 3. Okay, that gives me -3. But wait a minute, I want +3. So I'm almost there. So what that means is I need to change the sign. So if I change it to a +6 and a -3, that adds to be that +3. So +6 and -3. These are the 2 dimensions of our rectangle. We don't know which one's the length and the width or base and the height, but we do know that these are our 2 dimensions for it. Again, we did take a look at this yesterday. If you do not know how to factor that by hand, you can plug this in and you can find the roots, the x-intercepts. So if -6 is an x-intercept, you're going to see x plus 6, think the opposite. And here, +3 is an x-intercept, think the opposite, x minus 3. All right. Now, let's go on to this. Now, we don't have something we can plug into Desmos on this, so we have to look at this graph, all right? Be ready to be given graphs and find the following. All right, x-intercept. So I have 3. It's crossing at -3, 0. It's also crossing at 2, 0, and it's also crossing at 5, 0. Now, is there anything special about any one of these? This right here, this is a double root. The reason why it's a double root is because it bounces off the graph right there. All right, y-intercept. Where's it crossing the y-axis? Right here at -2. So the way we write that is 0, -2. And if it's a function, there should only be one y-intercept. All right, degree of this function. Now think about it. Here, this one's a double root, so this is going to happen twice. So if I have basically -3, 2 happens twice, and then I have 5, look how many roots I have. So this should be degree 4. All right. At least degree 4. Now, there are in which we haven't covered yet. There could be imaginary roots that you're not seeing here, but this is at least degree 4. Okay, relative max. Max, think of it's increasing and then decreasing. It's got that high point. Relative max is right here. It's not the actual maximum, okay, but it's just relative. So 0, nope, actually the other way around, 2, 0. All right, relative min, I have 2 of them. One is right here and one is right here. We're going to just approximate these. This one, we're going to say it's at -1.5, and then the y value's at -4. All right, my other relative min looks like the x value is 4 and the y value is -1. Now, interval of increasing and decreasing. Okay, so interval of increasing is when it's going up. So it's going to be right here and right here. Okay, so interval of increasing, I did an orange right here. You're using your x values. We said that's at -1.5. All right, to this x value, which is 2. You put a u because I have a second interval, and that's from 4 to infinity. All right, now interval of decreasing. All right, let me grab a different highlighter. This one is going down, and I notice I have 2 that's going down. Start from the left-hand side. This is -infinity over here. Then I'm going to this x value of -1.5. All right, and then I'm picking it back up with a second interval, and I'm going to go to 2 to 4. So if you notice, it's like in between these two, and then this one's on the other side of that. All right, now do you remember what this means? Now, I really just have written positive sometimes. Okay, positive means above the x-axis. All right, so let's see if I can pull another color out. All right, above the x-axis. This right here is above the x-axis. And so is that right there, above the x-axis. So we're going to write those intervals. All right, so this one, starting from the left, we always start from negative infinity. Always write the x values to that x value of -3. And then it picks back up right here. It looks like it's crossing at 5, okay, to positive infinity. Well, the rest of this is down low. It's below the x-axis. All right, let me do this in green right here, all of this. Now, we do have a little hiccup here because it actually hits the x-axis at 2. So watch how I write this. All right, this is when it's negative. Write this down below x-axis. All right, just so you can recall that and remember it. All right, and when it's below the x-axis, I pick up here at -3. All right, now I'm going to go to 2 because remember when it hits the x-axis, it equals 0. So therefore, 0 is not positive or negative, so we leave it like that. And then my second part of that interval is going to go from 2 to 5. All right, so there's our warm-up, and then we're going to continue with our lesson on polynomials. All right, so we're on page 160. Let's take a look at this one. I'm just picking out D, and I just want to, let's review like everything that we've kind of discussed so far. Now, I do have this question, which I haven't posed before. How many possible roots? All right, now just think about what the degree is. The degree is 3, and that's how many possible roots that we can have. We can have 3. Now, I went ahead and graphed this in Desmos so that we could go ahead and see it. All right, where's the y-intercept? Now, you can see that on the graph here, down here. The y-intercept is here. Or remember, the y-intercept is just this constant right here, if it's written out in this form, not factored form. All right, so the y-intercept is 0, -24. And again, you can check this on Desmos, so please check it. All right, relative max. Remember, that's when it goes up and comes back down. Well, we have one of those up here. So here's our relative max, and I'm going to write it down. -3.082 and 6.041. And we can have more than one of those, so just know that. All right, relative min, that's when it goes down and comes back up. So we have another relative min right here. It is at 1.082 and -30.041. All right. Now, if they ask for the relative max value or min value, you want the y value there. Okay. Now, interval of increasing, where is it going up? So interval of increasing, I'm going to start from the left. Right here, we're increasing all the way to, and remember, we're using the x values. So I'm going to start at -infinity. And then I'm going to go to that x value of -3.082. All right, now I start to decrease. So I'm going to start writing that x value of -3.082. And then it decreases all the way to this min value of where the x is 1.082. Okay, and then we pick it back up and it increases and it just keeps going on forever. So I'm going to go back up to increasing and I'm going to say 1.082 off to infinity. Oops, there you go. Now you can see it. All right, now remember, this is where it's positive. This is when it's negative. So positive is below the x-axis. Let me take these, above the x-axis. All right, so where is it above? From here to here, from -4 to -2. And then again, it's above from this point at 3 onto infinity. All right. Now, less than is when it's below the x-axis. So here, it's below the x-axis down here, starting at -infinity, all the way to this value of -4. Okay, and then it goes below this little loop right here from -2 to +3. So -2 to +3. And if you notice, this -2 to +3 fits in between right here. All right. So again, be able to pick all of these things out. All right. Now they could just ask you one question, where is it increasing? And you got to be able to pick that out where that is. All right. Or where is it positive? How many roots? So forth. All right. So let's switch over to page 161 and we want to look at activity 2 down here. Okay. Now, let's look at these graphs right here. Using technology to graph both these functions, you can graph them in the same window, -10 to 10 and -100 to 100. Okay, how are they the same and how are they different? All right, so here we go. We're going to graph both of these. All right, so the first one, x minus 2, x plus 3, x minus 7. So here's that first graph. All right. Now, if you want to change it to the window of -10 to 10, so here it is. If you hit this wrench right up here, we can see our x's go from -10 to 10. These are our y's. If you want to change it, you're welcome to. Actually, it does say take the y to -100, 100. Okay, we kept the x at -10, 10. All right, so we can just switch it like that. Now let's put the other one in, 1/2. All right, and then it's x minus 2, x plus 3, oops, and x minus 7. All right, so let's look at these graphs. We're looking at differences and similarities. So when I look at these graphs, what do they have? How are they the same? Well, they have the same x-intercept. All right, it looks like they're increasing in the same places. They're decreasing at the same places. And it looks like they're positive on the same places. And then they're negative on the same places. All right. But what is different? Well, if you notice, the y-intercept is different. Okay. Where our relative max and our relative mins, those are also different. So you see right here, this min's here, this one's here. Okay. And it looks like the red is like been stretched. Okay. If you notice, all we've done here is just multiply this by 1/2. Okay. And we multiply it by 1/2. Think about it for a second when we talked about those transformations with absolute value. When I multiply by 1/2, what does it actually do? It compresses our graph. And so that's what we have done. We have compressed our graph by a factor of 1/2. All right. And what it does is it changes our y-intercept. And if you actually look, the y-intercept here is 42. Well, think about it. 1/2 of that is 21. All right. So that's what we've done. All right. So let's keep moving on. Okay, now we're going to ask these same questions. So flip over to page 162. All right, what degree do these polynomials have? Well, I rewrote this because it was on another page. Well, both of these have the same degree. Like here, I'm multiplying x times x times x, so I get x cubed. My leading coefficient, I'll call it LC, is 1, and my degree is 3. Well, here, now you have to include this 1/2 when you go and multiply the x's. 1/2 times x times x times x. This is 1/2 x cubed. Now here, my leading coefficient is 1/2, but my degree is still 3. We didn't change the degree here, okay? We just changed my leading coefficient. All right, so number 3. Now, let h of x equal, what do you think the graph will look like compared to? Well, I want you to look at this. This still has x plus 3, x minus 7 like the others have, but I want you to look here, 3x minus 6. Does anybody notice anything about this? If you notice a 3 goes into this, we can actually factor a 3 out. Think about that GCF that we did the other day. Like that. Okay, so now let's look at it. The graph. This looks very similar to our other two. It's still got x minus 2, x plus 3, x minus 7 like the other one, but instead of multiplying by 1/2, we've multiplied by 3. So if I actually throw this into the graph and I change this time it stretches our graph. We stretched by a factor of 3. And all those things that we just said that were different, our relative max, relative min, and our y-intercept, they're different here. Well, and guess what? Here, the y-intercept was 42. Well, if I multiply by 3, think about what you're going to get. Whoa. Look where our y-intercept is now, 126. 42 times 3 is 126. So we can find our new y-intercept there. Okay, so it's just going to be stretched by a different factor of 3, different relative mins, maxes, and y-intercept. All right, so let's go and look. Are you ready for more right below that? And they give us two graphs. All right, So here we've got two graphs. Notice they have the same x-intercepts. They have the same like intervals of increasing, decreasing, positive, negative. The thing that's different is our max, relative max, our relative min, and our y-intercepts. Now, notice this. We're taking our original function. So here are two graphs of the polynomial function, m and n. We know that n of x, n is the smaller one, this one, and I'm going to highlight it in yellow. You may want to do the same thing. All right, this one's n right here. Okay, so my yellow graph in this one. Okay, why do the two graphs have different vertical intercepts but the same horizontal intercepts? Well, the reason is because we multiplied by a number k. And how can we find this number k, which is what number 2 asks us? All right, well, this is how we can find it. If we take, we want to take n, and just think about this. N, our y-intercept is -1. All right, k, and here, where's our y-intercept? It's -5. All right, so what do I need to multiply by to get -1? Or just think about solving this equation. Here, if I divide by -5, all right, I get k to be 1/5. All right, so if I multiply m by 1/5, it's going to give us n. So k equals 1/5. So if you just take this, taking this equation right here and you plug in your y-intercepts, you can figure out what you're actually multiplying by. All right. Okay, let's move on to page 163. All right, so 163, we want to look here. Write a possible equation. You can do this in partners. I'm going to just do it kind of showing you. All right, write a possible equation for a polynomial whose graph has the following horizontal intercepts. Okay, remember horizontal intercepts is talking about our x-intercepts. Check your equation using graphing utility and then compare your equation with your partner. All right, so here, this is an x-intercept of 4. All right, think opposite. Our equation's going to be y minus 4, and that's our only one. All right, if we graph this, our x-intercept is, all right, x minus 4. You can just double check it. All right, you can see the x-intercept here is at 4, and that's our only one. All right, moving right along. Let's look at this next one. Now, this time they give us 2 of them. All right, so our equation, you can write it out in factored form. Think opposite. You just want the x's right here. X minus 0, x minus 4. All right, now, here, you don't actually have to put x minus 0. A lot of times you'll just see x right here. You may also see, you can multiply this out, x squared minus 4x, like that. All right. So here, if I were to graph it, you're going to see the x-intercepts at 0 and 4. Okay. Now, and this one's degree 2. 2 roots, degree 2. Here, 1 root, degree 1. If it doesn't have an exponent, that's a 1 right there. Okay, let's look at B. Now, this time I have 3 roots. So think about it. What's my degree going to be? Degree 3. All right. Y equals, if it's -2, it's going to be x plus 2. If it's 0, x minus 0. Here, 4, x minus 4. I'm going to clean this up a little bit. X minus 0 just means x. X plus 2, x minus 4. I'm not going to multiply these out. I'm going to leave it like that. All right. And again, if I graph this, and you may want to verify this, okay, if I have x, x plus 2, and then x minus 4, all right, we set our x-intercepts would be at -2, 0, 0, 0, and 4, 0, and they are. All right, here we go. And one last one. See if you can write this on your own. If I see -4, I'm going to say x plus 4. If I see 0, you can just put x now. You can put x minus 0 or x plus 0, but it's really just x. All right, and then 2 means x minus 2. Do the opposite. All right, so with our partner, or let's think about this. Let's develop a new equation with horizontal intercepts. Now, what have I done here that I did not do in the other ones? Do you see how there's a fraction here? Well, I'm going to show you a trick to this. All right, here, if it's -5, I'm going to put +5. If it's 1/2, I'm going to put x minus 1/2. All right, if it's +3, I'm going to put x minus 3. Now, we don't want to leave equations like that, okay? typically you don't see a fraction in there. So what I'm going to do, I'm going to do a trick. All right, this is not mathematically right, but I'm just going to do a trick. If you take this 2 right here and you move it here, oops. So x plus 5, this is 2x minus 1, all right, and x minus 3. Okay, this, if you graph this equation right here, you will notice that it has x-intercepts at the things, the places they have said they will be, like that. And all of these are integral coefficients. All right, I don't have any fractions, but you do see 1/2 as that root, like they said it was going to be 3 and -5. All right, moving on. Let's turn to page 164, flip it over one page. Now determine the equation in factored form of the polynomial. All right, so here we go. Now, one of the things I see here, -3 is a root, so x plus 3 is a factor. -2 is a root, so x plus 2 is a factor. All right, 1 is a root, so what's a factor? Think opposite, x minus 1. Now, the only other thing here is, did I multiply this by some value? We're going to say k. All right. Now, here's a quick way to figure this out. Go look at the y-intercept. If you just multiply these constants, 3 times 2 times -1, that's -6. Is that where my y-intercept is? No. All right. So here, what do I need to multiply -6 by? And notice where my y-intercept is. It's at -12. So put what it actually is by itself. We're multiplying the -6 by k. All right. If I divide by -6, I get k equaling 2. And think about it. 2 times -6 gives me -12. So this is our graph right here. So 2, x plus 3, x plus 2, and x minus 1. Always verify, okay, is that correct right there? All right, so 2, x plus 3, x plus 2, and x minus 1. All right, here, oops, that is the minimum. You got to make sure you're getting the y-intercept. 0, -12, which was on our graph. The other one that was on our graph that they gave us, and I'm going to write this, 2, 40. Whoops, the point. Okay, and if I go and find that point, there you go, that point's right there. And is it on the graph? It is on the graph. All right, so I know I have the right equation. So if you look at your y-intercepts, you can see if you need to multiply by anything. All right, and right here, write a cubic equation in factored form. Okay, so here, if anywhere y is 0, that's our x-intercept, so x plus 4. All right, here, x minus 1, and then I have another one here, so I'm going to say x minus 6. Now, here's my only thing I have to be careful of. Let's see if all these points are actually on there. Okay, including that 315. So x plus 4, all right, x minus 1, and x minus 6. All right, and let's see, is 315 on, ooh. Okay, so 315, is that point on there? All right, when I see 315, ooh, I don't see it on there. Let's see if it's not running through there. So I've got to see, how am I going to get it to run through there? All right. One thing you can try to do is, what if I add a negative? Well, that did flip it, but wait a minute. Here, let's see. Well, this is how we're going to do it. If you can't figure it out using Desmos, and sometimes you can't, what we're going to do is we're going to take k value equals y. Well, this is x and this is y. We can figure out that k value by plugging in 15 for y, and we're going to plug in 3 for x. We're going to do this by hand. Okay, that gives us 7. That gives us 2. This gives us -3. All right. This is another way to figure out K, but we can do this by hand. All right. When I multiply these numbers together, 7 times 2 times -3, I get -42. So 15 equals -42K. And think about, how do we solve for K now? We divide by -42. All right. So now our calculators, you can reduce this. And watch this. If I do 15 divided by -42, okay, it gives me a decimal. That's okay. Now, in your calculator, if you're using this calculator, hit math, and then we're going to hit 1. So just press enter and then enter again. And guess what? It reduces it to -5/14. Or if you knew 3 goes into here 5 times, 3 goes into here 14 times, guess what? You found the K value. So our equation, we'll call this g of x because that's what they said, is -5/14, kind of an ugly number, x plus 4, x minus 1, and x minus 6. All right, so we can write the equation for that and even come up with the K value for it. All right, now we're going to move right along. Let's look at a couple more things. I've flipped over to page 174. All right, now I want you to look at these two graphs. Give me some things that you notice. All right, and think about the ends of the graphs too in this. Now, one of the things I notice is that this is degree 3. Okay, and look at the ends. One goes down, one goes up. All right, this is degree 4. One goes up and one goes, and both of them actually go up. Now, if we go and investigate this further, what you're going to find is that anytime it's odd degree, the ends go in opposite directions. So what I mean by that is one end is going to go down while one end goes up, or you could be flipped around like that. Okay, the first one goes up and the last one goes down. Okay, degree 4, or anytime you have an even degree, like when you have degree 2, think about a quadratic, degree 6, degree 8, the ends both go in the same direction. All right, and when they go in the same direction, they either both go up, like here, or they both go down. All right, and you can have some turns and max and mins along the way in there as well. All right, so we're going to turn to page 178, and let's think about some of these properties right here. All right, number 1, we want to write an equation for a polynomial with the following properties. Has an even degree. It has at least 2 terms in it, and it has the inputs approach infinity in either the negative or positive direction. And I'm going to write this out like this. As x approaches infinity, the outputs, that's the y values, approach negative infinity. So f of x approaches negative infinity, but also as x approaches negative infinity, f of x approaches positive infinity. This is called end behavior. All right, and what this looks like, if you think of a y-axis or x and y-axis, this is x and it's negative infinity. This is x, and on this side is positive infinity. When x is going to negative infinity, whoops, both of these are going to negative infinity, sorry. It's going down. All right, same thing here. This is going down. Who knows what it's doing in between? All right, but it did say even degree. That could be 4th degree, 2nd degree, 6th degree, whatever. Okay, here the one I drew up has 4 roots, so it could be a possible 4th degree. All right, here we go. It has to have at least 2 terms. So what if I say x to the 4th minus 2x? All right, doesn't matter what the next term is. All right, but here's the key. To make both ends go down, because if I were to graph this, you would notice both of these ends go up. To make it go down, that leading coefficient has to be negative. All right, you can even write it out like this. This would be 2 different equations, all right? But you would notice both ends go down. All right, here we go. Let's look at number 2. Write an equation for a polynomial with the following properties. This time, odd degree, so degree 1, degree 3, degree 5, has at least 2 terms in it. As the inputs approach negative infinity, so as x goes to negative infinity is what this means, f of x goes to positive infinity. So what that means is on this end, this is x is going to negative infinity on this end, f of x, our y values are going to positive infinity. All right, now as x approaches positive infinity, our outputs approach negative infinity. All right, so on this side is x going to positive infinity, but our y's are going to negative. Now, who cares what it's doing in between? It's just we're talking about our ends right here. Now, odd degree, just pick an odd degree. We'll say degree 3. You can say degree 5 if you want, at least 2 terms, just add a term in there. Let's just add x, or you can add a constant, doesn't matter. All right, now you want to look, anytime you want to look is you want to look on the right-hand side, say this one right here. Okay, if this end is going to negative infinity, like both of these are, then our leading coefficient is going to be negative right there. All right, if it was going up, it would be positive. Now let's look at this. In the given graph, all the horizontal intercepts are shown. Find an equation for a function with this general shape. Okay, so we're going to bring in some things that we've done. X-intercepts are at -4, so that's x plus 4. There's an x-intercept at 3, so x minus 3. Here's one at 10, so x minus 10. Do the opposite. Now, do you see how? Now, I'm going to write this just so you know. On this end is as x goes to negative infinity, f of x, because it's going up, is going to positive infinity. All right, this is how we write in behavior. On this end, always on the right-hand side, is x is positive, but this time, because this is going down, f of x is going to negative. All right, and again, to figure out if that leading coefficient is positive or negative, only look at the right-hand side. Well, this one's going down, so this is going to be negative. All right, this could be, and since we don't know what this y-intercept, I mean, that could even be like a -2 if we wanted to write that right there. The k value can be anything. It's just we know it's going to be negative because this one is going down. All right, so that is a little bit of in behavior. We talked about roots. We've talked about increasing, decreasing, positive, negative, y-intercepts, x-intercepts. We've talked about a k value as well. So be able to discuss these things about polynomial functions and always check them in Desmos as well. And always ask your teacher if you have questions.